Okay, welcome back. We're ready to do 7.2.2, and we're going to start here with properties of ionic compounds. So, most ionic compounds are crystals or crystalline at room temperature, meaning they're solids, and they have a regular arrangement of three-dimensional patterns, and this is where we get most of our gemstones. They're actually from some kind of crystals. So, calcium fluoride is a very interesting crystal, I think, as is the second one shown here. We have a few more pretty pictures. Each ion is strongly attracted to each of its neighbors, and repulsions are minimized, and that's very important. And it gives rise to a second property, which means it's very stable because it has this regular packed crystal structure. And if you were to hit it with a hammer, it actually will shatter rather than crumble like a covalent compound would. So we have beryl here as the first picture with this pretty green substance. We have hematite, and we have cinnabar, which is also, I think, very pretty. And they generally have very high melting points. The melting point for sodium chloride is around, I think, 900 Celsius, which is really high. So, would you expect to find sodium chloride underground in rock deposits as a solid, liquid, or a gas? This sounds like an easy test question to me, and you should answer this since you have sodium chloride on probably your kitchen table. It is a solid at room temperature. As you can see also in the picture, it should be a solid. Oh, here it's 800 Celsius is the melting point for sodium chloride. Now, it does dissolve easily in water because it is ionic and water is polar. It does dissolve very well in water as well. Coordination numbers is something you need to be exposed for, and it's just saying how many nearest neighbors does a particular anion or cation have. And so the coordination number for sodium chloride would be 6, because if you look at maybe this purple one here in the center, it has one on the top, one on the bottom, one to the left, one to the right, one to the back, and one to the front. And so that would be 6 coordinations. I'm not going to ask you a lot about it, but I do need you to know the definition for coordination number. And so here they're giving you a little bit bigger picture of it so you can see it a little bit better. And here is cesium chloride, and it has a coordination number of 8. And so not all one-to-one relationships even have the same coordination number, so you can't really derive it from the formula. It's done by experiment. Titanium dioxide. Oh, I think this is going to be it. I want you to write in your note, what is TiO2 used for? And I'm about to tell you. It is a very white compound, and titanium dioxide is used in the cream filling of Oreos. Yes, isn't that gross? But it's actually perfectly fine to eat it. It's also used to make other things white, like clothing can be dyed with titanium dioxide. They use it in plastic manufacturing to make a plastic white, but it is used in the cream filling of Oreos. So that's your second one. And I think we'll have a third one a little later on. Okay, ionic compounds can conduct electric current in only 2 states: if they are melted, which would be at high temperature, or if dissolved in water. So in a solid form, they would not conduct electric current. And so when sodium chloride is melted, or the orderly structure breaks down, and now we have ions that are free to move and conduct current. And that's the same thing that happens when you have it in water. Those ions are free to move. They would carry the charge from the anode to the cathode, and so we would get current that would be transferred. Solar panels are really interesting. They use molten sodium chloride for its ability to absorb and hold a large quantity of heat because it has such a high melting point. And then that's used to generate electricity. I wish we lived in a little bit sunnier climate, and I would probably get solar panels. They're very useful out in places like Phoenix, Arizona, places with a lot of sun. Ionic compounds also conduct electric current if they are dissolved in water. And that's because, again, the ions are free to move. So you can conduct current only if they have ions or charged particles that are free to move. So I think the second one for here is going to be the answer to this question. It says, when can ionic compounds conduct an electric current? And so you should write your answer down. And of course, it's on the next slide. So if you're not sure, it can only do it when melted or dissolved in water. So that's your second one or third one for this series of videos. Oh, just in time, we are at the key concepts. Although they are composed of ions, ionic compounds are electrically neutral. So we are going to have to figure out how many positive ions to how many negative ions so that we can get to a neutral state for that compound. Most ionic compounds are crystals and solids at room temperatures. Ionic compounds generally have high melting points, and they conduct electric current when dissolved in water. You should know your vocabulary: ionic compound, ionic bond, chemical formula, formula unit, coordination number. The big idea: electrostatic forces between oppositely charged ions hold the cations and anions together in an ionic compound. Ionic compounds generally have high melting points and can conduct electric current when in solution or when melted. And that's the end of this video. Thanks for listening, and I will see you in class. Have a good day.